All right, some more measures of position, page 3 and 4, quartiles. Interquartile range, IQR, is a measure of spread based on the data being divided into 4 parts. Okay, each part's called a quartile. So you have quartile, you look at this data set here, quartile, the first quartile, the second quartile, and the third quartile. First quartile, second quartile, third quartile, fourth quartile. Okay, these are divided by the Q1, Q2, and Q3 when you have a nice ordered data set. Okay, this data set right here represents the ages of 18 students taking winter session. So the N is 18. So when you have them all nicely laid out, the median, since it's an even number, is between the middle 2 numbers, so the median falls there. Okay, and then the median of the bottom half, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in the bottom half, is an odd number, so the middle number is the median of the bottom half, which is Q1. Okay, the upper half has also 9 numbers, so it's an odd number, so the middle number of those 9 is the median of the upper half. Okay, the median of the entire data set is Q2. Okay, each of the quartiles represent 25% of the data. The 2 quartiles in the middle represent 50% of the data, and we call them the interquartile range. So to calculate out the range, it's Q3 minus Q1. That gives you from data to data point the range. Okay, the outlier formula is now here, so when it's ordered you can figure out what would be an outlier if you had one. So let's look at this data a little closer here. We have an IQR calculated out. Q3, which is 25 minus 18, is 7. So the middle 50% of the students' ages do not differ more than 7 years. Okay, the median's 21.5. Oops, no, 20. 20.5. And then the spread's only 7 out from there for the middle 50%. To figure out our outliers, we're going to take our low outlier, Q1, minus the interquartile spread of 7 times 1.5. You're going to get 7.5. So anything below 7.5 would be an outlier, so we clearly don't have an outlier on the low end. But if you take Q3 here and add the 7 interquartile range times 1.5, you're going to get 35.5 for an upper end. Okay, so the 42 turns out to be an extreme value or an outlier. There is a gap of 9 here. So that would be an unusual number right there. So remember, you have to line them all up to figure all those things out. And you can also put quartiles as represented by a box and whisker plot. Box and whisker plots can be made from your 5-number summary, which is your min, your 1, your 2, your 3, and your max. Okay, again, still 25% in each whisker, or the first quartile and the last quartile, and the 50%, the interquartile range, is the box. And then typically you'll see a number line underneath when you have to make one, so you get the proportions of the box and whiskers correct. Okay. Again, you still needed an ordered data set. The ends of the whiskers are going to be your outliers. Your vertical here are going to be your Q1, 1, 2, and 3. And remember, the median is not the center of the box. That's different. Okay. The median is where remember where the actual center of the data is. So you could have a box with this up here, and then you have big space down here. interquartile range is the same. Mid-quartile is the center of the box. So it's kind of like finding the midpoint of a box. You're going to add Q1, Q2, Q1, Q3 together and divide by 2. That gives you the center of the box, which is typically different than the median. Okay, and then you can work on your visualizing your percentiles on this too. So if you have, say, a 75 percentile, that means 75% of the data of the student's values or whatever it is fall below, at or below there. Because remember, this is 25, 25, 25, and you can still find kind of your other ones as well. So this is 25%, whatever the numbers are. So let's look at an example of that. Steps to drawing a box and Whisker by hand. Find your 5-number summary if it's not given to you. Okay, so you have to do all the calculations to find it out. This example hands it to you, so you need to start by constructing your horizontal scale or number line. So I'm just going to draw a big number line. The box is going to go above it, okay? But I need to know where all the values are to get my proportions. One advantage of a box and Whisker is it physically looks like the quartiles are proportional to what the data is telling us. So it's kind of an at a glance of the data. So we want to make the scale right. So let's look. I have a minimum of 45 and a maximum of 96, which means I really shouldn't start at 0. I want to start maybe at 40 and end at 100. That would get everybody. And then I could go up by 10s, 50, 60, 70, 80, 90, and then sometimes when I do this badly, I have to adjust the end a little bit. I kind of 50, 50, 60, 70, 80, 90, 100. Okay, that should do it. And then I want to put in my min, which is at 45. So that's right here. That's going to be the end of the Whisker. And I tend to write the numbers right on there just to make sure, because if I'm doing kind of a hand-drawn thing, it doesn't always look perfect. Okay, so they're the end of the Whiskers. And then the center, let's see, median is Q2. So 78's right about there. It's going to be a vertical line for Q2, and that's 78. And then the Q3 is 83, so I'm going to put that right here, 83 for Q3. And Q1 would be 69. Let's just put that there. So this is my box. And these are my Whiskers. Okay, so that's proportional to this. What a nice visual of what the data is telling us. And then they're going to ask some questions about these. What was the average or median test score for the class? That's what is Q2. So 78. Scores range from 45 to 96. Your score was 83. Does this mean you're in the 83rd percentile? No. Remember, we have to figure that out. I don't have all the data sets, so I can't calculate out what it would be. But for B, it says if 75% of the students scored at 83 or below, what is your percentile? So that kind of confirms, see where 83 is Q3, so it has to be at 75th percentile. Okay, if there were 40 students in the class, how many students got a score above an 83? Well, 100 minus 75 is 25. So 25%, right? These are percents. So if we had 40 students, you can multiply that by 0.25 and you're going to get a 10. So 10 students scored above, or 25% of this class scored above an 83. Let's say your score was at the 90th percentile. What percentage of scores were at or below your score? 90%. Above, 100 minus 90 is 10. Interquartile range of this data would be Q3 minus Q1, so that is 83 minus 69 is 14. That's the spread of the smallest quarter. What does that tell you about the scores? The smallest quarter visually is the third quarter, right? The third quarter is from 83 to 78. The smaller means what? The smaller means that you have kind of packed scores. If each of the whiskers are 25% of all the scores, and each quarter of the box is worth 25% of the data, then a smaller size quartile visually indicates the packed data around those numbers. So there are just as many in there. So I would say, since the third quarter is the smallest, it contains the equal number of data, so that there were more students that scored between a 78 and a 83 than anywhere else. Okay, 72 falls into the second quarter. The first quarter has the largest spread. That means this data is somewhat skewed. Left, right? Correct. So it goes left. So the person who got the 45 here might be an outlier. So this is skewed left. So that means kind of the average gets pulled down by the person who did not do well for that 45. Is it that 45 an outlier? Is it an extreme value? Remember, the outlier formula requires the IQR first, and we found out above that was a 14. So the formula for a low outlier is that. So Q1 was 69 minus the 14 times the 1.5. So that's going to give you 48. So yes, think about it. We're going down the scale. 48. 48, anything this way is a low outlier. So our 45, yes, that's an extreme value.